Hello, and welcome back to the final IB Math speedrun of Chapter 6 with me, Vince. So we're going to be going through the exam review of Chapter 6, which will cover everything we've learned in this chapter. So let's jump right in. Hello, sorry about that, and let's jump right into the chapter review. So the first question is, a costume hat is formed by attaching a cone to a hemisphere. The radius of the hemisphere is 6 centimeters and the total height of the hat is 14 centimeters. Find lagging. Find the volume and the surface area. Okay, so if the radius of the hemisphere is 6, this is pretty vague, so I'm gonna assume they stitched the cone like that and the hemisphere like this. If the total height is 14 and the radius of the hemisphere is 6, that means the height of the cone is 8. So for the volume, we have 2/3 pi r cubed, in this case pi 6 cubed, plus 1/3 pi rh. Pi times 6, which is the radius, times 8, which is the height. So we should get this equal to 2/3 times 6 cubed, 144 plus 6 times 8/3, 160 pi. Oh, sorry, this should be 6 squared. Sorry, 2 times 6 cubed over 3 plus 36 times 8/3. So we should get 240 pi as the total volume. Next, for the surface area, well, we need to find the surface area of the hemisphere. And I think we're ignoring the middle section, so this would be simply 2 pi r squared. And then we need to find the surface area of the round bit of the cone, which is a bit more complicated. It is, this is circle, so this is pi slant height squared. Wait, no, it's not. This is circle over 2. This is pi r times, it's slant height, so it would be, we need to calculate a slant height, so this would be pi times r times the slant height, which is the square root of h squared plus r squared. Let me just remove this over here. So what we have here is 2 times pi times 6 squared plus pi times 6 times h squared, which is 8 squared plus 6 squared, which is equal to 10. So this is 10, so we have 72 plus 60, so we have 132 pi as our answer. Yeah, so let's just check that those answers are correct. And they should be. Where is the question? The question, so 240 pi is equal to 753, yep, and then 132 pi is equal to 414, yep. So that is correct. So on to the next question. So the next question is, find the values for cosine x which satisfy the equation 6 sine squared x equals 5 plus cosine x. So to do this, we need to rearrange this equation a bit. So we can get from this 6 minus 6 cosine squared x, since sine squared plus cosine squared equals 1, is equal to 5 plus cosine x. So we have 6 cosine squared x plus cosine x minus 1 is equal to 0. So we have 3 cosine x minus 1 times 2 cosine x plus 1 is equal to 0. So the values would be cosine x is equal to 1/3 or negative 1/2. So next, part B is we need to find all the values of x which satisfy the in the interval of x in the interval 180 is less than or equal to x is less than or equal to 540 degrees that satisfy this. Okay, so this is pretty simple. This is cosine x is 1/3 or negative 1/2. So if we were to, I guess, plot this on a graph, at 180 degrees, cosine is negative 1, so our interval is here, here, here. And then 540 degrees, our interval is also negative 1. So it's everything in this interval. And we need to find the values for where cosine x is 1/3 or negative 1/2. So it's 1/3 around there, and it's 1/2 around here. So we'll find these values. We've located that there are 4 possible values of cosine x. So if you punch it into a calculator, cosine negative 1 of 1/3. And we're working in degrees, so make sure to swap to degrees. So cosine negative 1 of 1/3 is equal to 70.5, but that's not in the bounds, so we're going to go 360 minus 70.5. So this one over here is 289.5. This one over here we can get by adding this to 360, so we get 430.5. For cosine is negative 1/2, while we have cosine the negative 1 of negative 0.5. That's equal to 120, or 360 minus 120. So this is 240. And then we have also 480. So these are our 4 values. So yeah, that one's good. Now we can move on to the next one. The next one is express tan 3a in terms of tan a. And so this is pretty simple because tan 3a is equal to tan a plus 2a. So what we have over here is we can add these together. So we have tangent of a plus the tangent of 2a all over 1 minus tan a tan 2a. And then we can use double angle to expand tan 2a. So we have tan a plus 2 tan a over 1 minus tan squared a all over 1 minus tan a times 2 tan a over 1 minus tan squared a. So let's put this into the fraction, and this as well, I guess. So we have, or I mean, we can just multiply everything by 1 minus tan squared a. So we have tan a minus tan cube a plus 2 tan a all over 1 minus tan squared a minus 2 tan squared a. So what we have over here is we have 3 tan a minus tan cubed all over 1 minus 3 tan squared a. I think, yeah. Yep, okay, that's correct. So next, on to the next question. We have solve the following equations in the interval 0 is less than or equal to x is less than or equal to 360. And we have two we need to solve. The first one is sine x plus 60 is equal to cosine x. And the second one is tangent of a minus x is equal to 2/3. And tangent of a is equal to 3. Okay, so let's solve the first one first. So expanding this, we get sine x cosine 60 plus sine 60 cosine x is equal to cosine x. So how can we manipulate this one? We get cosine 60 is root 3 is 1/2, so we have 1/2 sine x is equal to, let's subtract these two. So sine 60 is equal to root 3 over 2. So we have 1 minus root 3 over 2, 2 minus root 3 over 2 times cosine x. So we know that tangent of x is equal to 2 minus root 3. And since we need to solve it in the interval 0 is less than x is less than 360, we're going to get two values. So x is equal to tangent minus 1 of 2 minus root 3. So x is equal to 15 or 195. Okay, so that's a pretty neat answer actually. I didn't know it simplified to that. Anyways, tangent of a minus x is equal to 2 over 3, and tangent of a is equal to 3. So we can expand this into tangent of a minus tangent of x over 1 plus tangent a tangent x is equal to 2/3, and tangent a is equal to 3. So let's substitute that in. We have 3 minus tangent of x is equal to 1 plus 3 tan x. So if we multiply both sides, we get 9 minus 3 tan x is equal to 2 plus 6 tan x. So we get that 7 is equal to 9 tan x. So x is equal to the arctan of 7 over 9, which is equal to 37.9 or 180 plus that. 180 plus 37.9 is equal to 217.9. So yeah, those should be the two answers. 9 minus 3 tan x is equal to 1 plus 2 plus 6 tan x. I don't know. I don't see the problem, so I think these should be correct. I'm not sure what the book did. Anyways, on to the next problem, which is find x if arc sine x plus arc cosine x over 2 is equal to 5 over 6 pi. So what we have here is sine to the negative 1x plus cosine to the negative 1x over 2 is equal to 5/6 pi. This is an interesting problem. I think we can use the trick that this is equal to pi minus sine to the negative 1 of x over 2. To save ourselves, can we do this? I don't see why not. What? So x over 2 is equal to cosine sine to the negative 1x plus 5, 6 pi minus sine to the negative 1x. Oh, and then use compound. Oh, okay, that's interesting. Would it work? Because then this is equal to cosine 5, 6 pi cosine sine negative sine cosine sine to the negative 1x plus sine 5, 6 pi sine to the negative 1x, which of course cancels out. This is just x, so it's sine 5, 6 pi times x. So this is x sine 5, 6 pi. And we have cosine of sine to the negative 1x. So we are getting a fraction. And this should input because cosine is equal to sine of 19 minus x. So let's clean this up a little. The cosine of 5, 6 pi is equal to root 3 over 2. So we have root 3 over 2. And then we can turn this into sine pi over 2 minus sine to the negative 1x is plus 1/2 x. So this is equal to root 3 over 2 sine pi over 2 x. So x sine pi over 2. Oh, wait, no, that's interesting. Hold on. So we can cancel this out with the x over 2 on this side. And so we're left with root 3 over 2 sine, or I mean cosine sine negative 1x, I guess, or sine pi over 2. Oh no. 3 over 2 sine pi over 2 minus sine to the negative 1x is equal to 0 actually. So sine times pi over 2 minus sine to the negative 1x is actually equal to 0. So, or actually, I mean, we could just leave it as cosine of sine to the negative 1x is equal to 0. That would probably be better. So inverse cosine of 0 is equal to pi over 2. So we have sine to the negative 1, x is equal to pi over 2. So x is equal to sine pi over 2, so x is equal to 1. The book says 0 is an answer, and I'm not sure about that. Sine to the negative 1 of 0 is 0. Cosine negative 1, 0 over 2 is, well, 1. I mean, pi over 2 technically. So I don't know how they're getting 0 as the answer. So I'm just going to say it's x is plus or minus 1 is the answer. I don't know how is x equals 0 as an answer. Anyways, on to the next question. There are 3 towns. A, B, and C are at sea level. The bearings of towns B and C from A are 36 degrees and 247 degrees. If B is 120 kilometers from A and A is 234 kilometers from C, calculate the distance and bearing of town B from C. Okay, so A is probably at the top. Actually, no, it's not. A is on the left, right? Because we have a bearing of 36 to B. And then we have a bearing of 247 to C. And B is 120 kilometers from A is 234 kilometers. Not to scale, of course. Calculate distance and bearing of town B from C. Okay, so we know the angle. This is like a triangle with an angle of 247. Oh, okay. So actually, it's so much that it flexes the other way. So it would be a triangle like this instead. So we have 211. So this is 211 degrees. So the remaining would be 360 minus that. So this would be 149 degrees. We know that B is 120 kilometers, and from A and C is 234. So now we can find this remaining line. Let's calculate the distance first. That's pretty simple. That's just label it BC. So BC squared is equal to 120 squared plus 234 squared minus 2 times 120 times 234 cosine 149. So this is equal to 120 squared plus 234 squared minus 2 times 120 times 234 times cosine 149 degrees. So we should get the length, squared is 295. So if we square root this, we get the number 342.5 kilometers. So that's the distance. And now we need to get the bearing. So the bearing is from here. This is C. What's this angle here? These two angles should add up to 180 degrees. If this is 36, and that was, this is 149 degrees, then this angle over here should be 149 minus 36 is equal to 113, and then we can find this angle here. 180 minus 113 should be 67. So BC should have a bearing of 0.67, I believe. And 342.5, this is correct. Yay. Okay, on to the exam style questions. So the first one is the diagram below shows a quadrilateral ABCD such that, and I'll just label it. Anyways, A, find the exact area of the triangle ABD. Next, show that BD is equal to 5 square root 5 minus 2 square root 3. C, find the exact value of sine CDB. And finally, hence explain why there are two possible values for the size of the angle CBD, stating the relationship. Okay, so the diagram looks like this. We have this here, that here. So this is 5. This is 30 degrees, this is 10, this is 45 degrees, and this is 13. So this is A, B, C, D. So first we need to find the exact area of the triangle ABD, and that's not too hard. That's just, we can go 1/2 AB sin C. So that's equal to 1/2 times 5 times 10 times sine 30, which is 1/2. So we get, this is equal to 25/2, 12.5 centimeters squared. I mean, yeah, it's in centimeters, yes. So 12.5 centimeters squared. Next, show BD, get the length of BD. So we can use cosine rule for this. So we have BD squared is equal to 5 squared plus 10 squared minus 2 times 5 times 10 times cosine 30, which is root 3/2. So this is equal to 25 plus 100, 125, minus 2 times 5 times 10 is equal to 100 times root 3 over 2. So if we factor this out, I mean, it's going to all be square rooted anyway. We get 5 times 5 minus 4. 4 over 2 is 2 root 3. So we get the answer that the book gave us. Next, find the exact value of sine C CDB. So we need to find this sine value. We know this side now. This side is here. Badonk, and we have 13. So we know that sine A over sine A, so 5 root 5 minus 2 root 3 over sine 45, which is root 2 over 2, should be equal to 13 over sine CBD. So if we cross multiply, first we can multiply that so it's 10 up here. And then we have root 2 and root 3, so let's multiply these. So we get sine CBD is equal to 13 root 2 over 10 times root 5 minus 2 root 3. Is that correct? Yeah. And so why are there two possible values for the angle? Well, that's because there are two possible values for this sine. One is going to be an acute angle and one is going to be an obtuse angle, and the relationship is that they are, is it called supplementary? I think it's supplementary angles. So if you add both of those angles that it could be together, it will add up to 180. So yeah, let's move on to the next question. 16. Solve the equation 2 cosine squared x is equal to sine 2x for 0 is less than or equal to x is less than or equal to 2 pi, giving the answer in terms of pi. Okay, 2 cosine 2x, 2 cosine squared x equals sine 2x. Okay, so this is going to be 2 cosine squared x is equal to 2 sine x cosine x. So cancel out those two, cancel out cosine. Well, I mean, okay, one case is cosine x is equal to 0. We need to bear that case. But the other one is that cosine x is equal to sine x. So for the first case, cosine x is equal to 0. There are two possibilities. X could either be 0 or pi. And for when cosine x equals sine x, in other words, tangent of x is equal to 1. This is pi over 4 and 5 pi over 4. So yeah, that was a pretty fast one, and that should be correct. Yeah. Oh, wait. Sorry, no, I messed this up. This is pi over 2 and 3 pi over 2. Of course, it's cosine, not sine. Silly me. Anyways, that's correct. So these four angles. Next, we have the question, prove the identity. And then I'm going to write it down somewhere there. And then hence, solve the equation. And I will write that down too. So the identity is that cosine x over 1 minus sine x minus tangent of x is equal to secant x. Well, where do we go from here? Okay, I'm just gonna do this the old way. Let's remove that text first, so we have some more space. And I'm going to cross multiply this. So we have cosine squared x minus 1 times sine x plus sine squared x all over cosine times 1 minus sine x. And of course, cosine squared x plus sine squared x is 1. So we have 1 minus sine x over cosine times 1 minus sine x. These two cancel out. So we have 1 over cosine on the left-hand side and 1 over cosine on the right-hand side, because 1 over cosine x is equal to secant squared x. That is the definition. Yeah. So hence or otherwise, we need to solve the equation cosine 2x over 1 minus sine 2x minus tan 2x is equal to root 2. So we need to solve this equation, and we can plug this in. It's the same format, except that we're using 2x. So actually, all of this left-hand side is simply equal to secant of 2x, and that is equal to root 2, apparently. So we have cosine 2x is equal to 1 over root 2. So 2x is equal to, do they give us a domain? Oh yeah, 0 is less than or x is less than or 2 pi. And of course, there's a little trick here, cosine. Anyways, let's convert to radians first. So if we get the arc cosine of 1 over root 2, we should get, not being silly, this should be pi over 3. Right? This should be pi over 3 and 2 pi over 3. It's pi over 4. Yeah, no, I'm being silly. This is pi over 4, and then 5 pi over 4. And we need to use a little trick where it can also be 7 pi over 4. And, pi over 4, 7 pi over 4. And it could also be 9 pi over 4. And, because 2x just has to be less than 4 pi, because x only has to be less than 2 pi. So this would be, mental math, 15 pi over 4. So the possible values for x are then pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. So yeah, those are our 4 values. Next. Find the equation of the normal to the curve at, and then the equation of the curve is sine y is equal to tangent of cosine x at the point pi over 2, 0. So it's probably better that we implicitly differentiate this. So we have, what is this? Sine y implicit is cosine y dy over dx is equal to, let's differentiate this, u is equal to cosine x, so negative sine x secant squared of cosine x. I believe that is the equation. So if we have to divide all of this, we have dy over dx is equal to negative tangent x secant squared cosine x. We probably could have rearranged this. Anyways, pi over 2 and 0. Oh wait, we cannot call that tangent of x because that is actually cosine y. So we need to, I'm going to cheat and just select all of that, copy and paste. Oh, that did not work out. Please just let me copy and paste. Yeah. Thank you. So we have that all over this. Okay. So if we plug in our values of pi over 2 and 0, what we get is negative sine pi over 2, sine pi over 2 being 1, so negative secant squared cosine x. Okay, so we have negative secant squared, and cosine of pi over 2 is equal to 0, so it's secant squared of 0 over cosine y, y being 0, so cosine y is 1. So it's simply negative secant squared over 0. and remember, this is equal to negative 1 over cosine squared of 0. Cosine squared 0 being 1, so we have negative 1. So we have the tangent. Remember though, so the tangent is negative 1, so the normal is actually equal to 1. So we got y is equal to x, and then the point is pi over 2 zeros, so it's obviously minus pi over 2. That should be the equation. Yeah, that's correct. Next, we have question 22, our final question, which is hella long. Over the course of a single December day, the highest temperature was 22 Celsius. The lowest was 12, which occurred at 3 o'clock hours. First, find the smallest possible values for a model. Find the model, a sine model, temperature with the smallest possible coefficients. And B, find the number of hours during which the temperature was above 20 degrees Celsius. Okay, so we have the lowest temperature was 12, which occurred at 3 hours, and the highest temperature is 22, which we assume occurred at 15 o'clock hours, since this is a sine wave. So the lowest temperature, the bottom should be at 0300, and the highest temperature should be 1500. So this entire thing has a period of, I guess technically it's, can we, I'm going to say this is a period of 24 for simplicity. It has an amplitude of 5, and it's shifted, this is 1/4. It has shifted a lot. It's shifted pi over 2, 0, 3, so this is 12, so this should be shifted by pi. I want to say 9 pi over 8. I think it is 9 pi over 8. And of course it's shifted up by 10. 12. Not 12. 22 minus 12, I cannot do basic math, is 10 over 10 over 2, 5, 10 plus 12, 17. Wait, what? No, it has to be even. What am I doing? 22 minus 12, 5. No, it actually is 17. Okay. So now we can model this as an equation a sine b of t minus c plus d, something like this. So amplitude 5. 5 sine horizontal stretch. This should be 2 pi over 24. So 2 pi over 24 is equal to 1 over 12 pi. So pi over 12 of t minus, and then this is the how much we're shifting it left by, which in this case is 9/8 pi. Plus 17. Is that correct? I think that's correct. Oh, it's in degrees. Oh, they're making us do it in degrees. Okay, in that case, the period is 360 over 24, not 2 pi over 24. So 360 over 24 is 15. And let me change this to be in degrees. 9 pi over 8 is equal to 9 over 8 pi times 360 over 2 pi. So 9 over 8 times 360 divided by 2. So it should be like 202.5. Oh, okay, that's interesting. I never thought of it that. Okay, that's why. Oh, okay. Interesting. Sorry, no, this should be expressed in hours. This is how many hours we're shifting it left by. In the case that it's 3 hours, we're actually shifting it left by 9. So it should be, 15 times 3, 5 sine 15 times t minus 9 plus 17. Yeah, so that looks correct. And so now we need to figure out how many hours, what is it? The temperature was above 20 Celsius. So 20, so we need to, actually let's simplify this a little. We can already subtract 17 from both sides, so we have 3/5 sine 15 t minus 45. 15 times sine 45 is equal to greater than 3/5, so 15 t minus 45 is in between sine minus 1 of 3/5. It's in radians, please. Sine minus 1 of 3/5 is equal to 36.9, and 180 minus that is equal to 143.1. So now we can subtract add 45 to both. So plus 45, so 188.1, and this is 36.9 plus 45. So 81.9 is less than or equal to 15t. So t is between 81.9 over 15. So between 5.46, I guess AM, and 188.1 divided by 15 is 12.54. Oh wait, 15 times 9 isn't 45. 15 times 9 is 135. So these two times, of course, are need to be added. So we have 36.9 plus 135 is 171.9. And 143.1 plus 135 is equal to 278.1. So if we get these two times by dividing it by 15, we should get 11.46. So like 46, i.e. 12, and 278.1 divided by 15 is 18.54. So this is technically, I guess, 19. So we have 19 minus 12, so this should be 7 hours. 7 hours above. Yeah, so that's all for the speed run. I hope you enjoyed it. Quite a long day today, and I hope to see you in the next one.